All right, guys, Mr. Antonucci here, and this is part two of the mid-year midterm review for calculus. So we're going to go over 15 problems here, and hope this is helpful to you. So what is the x-coordinate of the point of inflection of the graph of y equals blah, blah, blah? Well, point of inflection occurs when the second derivative equals zero and changes sign, or the concavity changes sign. So the first derivative, y prime, is going to be x squared plus 10x. Okay. Second derivative is 2x plus 10. That equals 0 when x equals -5. So if we make our sign chart, -5 here, test a value on either side. Let's go -6 and 0. So when the second derivative is evaluated at 0, you would get 10, which is greater than 0. And when the second derivative um, is -6, or evaluated at -6, rather, you would get -2, which is less than 0. So it goes from concave down to concave up, which is a change in concavity at -5. So our solution there would be choice D. Alrighty. All right, number two, if f is continuous on the closed interval a to b and differentiable on a to b, which of the following could be false? So this is the conditions for the mean value theorem, the extreme value theorem, and also the intermediate value theorem all apply here because the function is continuous on a closed interval and it's also differentiable in between. So part A is going to apply, and we're looking for the one that's false. So this one is true, so we're not going to pick that one. So be careful because that's basically the conclusion of the mean value theorem. B is actually the one that is the correct answer here. It could be false. That's saying essentially that f is going to have a critical number on the interval, which it doesn't have to. Okay, if your graph, if you go from A to B and you have a line, okay, it's continuous and differentiable on that interval, but the derivative is never equal to 0. Okay, the slope of the secant line is equal to the slope of the tangent line, has a max, has a min. So C and D also must be true because that's the extreme value theorem. Okay, so choice B here is the correct answer for that one. Number three, if x squared plus xy equals 10, then when x equals 2, dy dx equals. So we're doing implicit differentiation here. So the derivative of x squared is 2x plus, since we have a product of xy, we have to do the product rule. So derivative of the first, which is x, is 1 times the second, which is y, plus the first times the derivative of the second. Remember, the derivative of y with respect to x is dy dx. So we could subtract the 2x minus y, so subtract these two terms, then divide by x and set that equal to dy dx. Okay, and we know x is 2. All right, so if x is 2, we still need the y value, so we could take this equation and substitute 2 in for x. So 2 squared plus 2y equals 10. That's going to be 4 plus 2y equals 10. Subtract 4, you would get 6. Divide by 2, you get y equals 3. Okay, so if x is 2 and y is 3, so -2 times 2 minus 3 over the x value, which is 2. -2 times 2 is 4, minus 3 is -7 over 2. So number 3 is choice A, -7 over 2. Okie dokie. All right, number 4. What is the instantaneous rate of change at x equals 2 of this function? Instantaneous rate of change just means get the derivative, evaluate it at 2. Okay, so to get the derivative here, I see I cut my bottom numbers off here, but it's going to be okay. Um, so f prime is the quotient rule. So derivative of the top times the bottom minus the derivative of the bottom times the top all over the bottom squared. Now, you could waste time and simplify this whole thing, or since you're evaluating it and not looking for the simplified form, you could just plug 2 into this. Okay, so it'd be 2 times 2 times 2 minus 1 times 2 squared minus 2 all over 2 minus 1 squared. So the denominator, 2 minus 1 is 1, squared is 1. So here 2 minus 1 is just 1. 2 times 2 is 4 times 1 is 4. Here 2 squared minus 2 is 2. So you have minus 2. And then so you have 4 minus 2 over 1, which is 2. Choice D right there. All right, moving along. So we have the graph of the function shown there has a vertical tangent at the point 2, 0, and horizontal tangents at those 2 points. For what value of x between -2 and 4 is f not differentiable? So a function is going to not be differentiable when the derivative is 0 or undefined. Excuse me. A function is not going to be differentiable when the derivative is undefined. Those occur graphically when you have discontinuities, corners, cusps. Vertical asymptote would be an example of a discontinuity. Okay, so now be careful here because this is saying you're given the graph of f. This is not the graph of the derivative, but you're being asked questions about the derivative, essentially, given the graph of the original function. So at x equals 0, I have a discontinuity, and I know at x equals 2, I have a vertical tangent. Okay, at this point and this point, where you would have horizontal tangents, the derivative is not undefined there. The slope of the tangent line would be 0, which is a defined value. Okay, so this would be at x equals 0 and 2 only. So choice B for that one. Okay. Number 6, particle moves along the x-axis, so its position at time t is given by x of t. For what values of t is the velocity of the particle 0? So remember, velocity is the derivative of position. So that would be x prime of t, which is 2t minus 6. We want to know when the value of velocity is 0. So we would set this equal to 0. One common mistake is students will evaluate it at 0. You would get -6, which isn't even a choice there. Or they might evaluate the original function at 0, in which case you would get 5. But neither one of those are what we want to do. So you solve this for 0 and you get t equals 3, which is choice C. Alrighty. Now, number 7, I like this problem. This is one of my favorite problems. The graph of a twice differentiable function f is shown above. So we have the original function f. Which of the following is true? We have a bunch of inequalities here talking about the values in relationship to one another of f, f prime, and f double prime at 1. F of 1, we can get it because on the graph, that's an x-intercept, so we know this is 0. F prime of 1, we don't know what the slope is there, but since the graph is increasing through that point, we know that the derivative has to be positive there. And the second derivative at that point, again, we don't have an equation to take the second derivative or anything like that, but the graph is concave down, so we at least know that the second derivative is going to be less than 0. So we're looking for the inequality, since these are all less than symbols, at which the second derivative comes first. So these 3 are going to be eliminated because the second derivative has to be less than, since it's less than 0, it's got to be less than f of 1. And since f of 1 is 0, it's got to be less than f prime of 1 because f prime of 1 is positive. So it's choice D for this one. Really like that problem. Number 8, an equation of the line tangent to the graph of y equals x cosine x at the point 0, 1 is, so for equation of a tangent line, we need a point, which they gave us, and we need the slope, which is equivalent to taking the derivative and evaluating it at the x value. So the derivative of x is 1, cosine's derivative is negative sine x. So if I plug in 1, or excuse me, 0. Sine of 0 is 0. So this is the slope. So remember, y minus y1 equals the slope times x minus x1. So y minus 1 equals the slope 1 times x minus x1, which is 0. This point here is our x1, y1. So you have y equals 1x plus 1. All right, that's going to be choice B right there. Okie doke. That's all we got to do for that one. Number 9, the function is given by f of x on which of the following intervals is f increasing. So a function is going to be increasing when f prime is greater than 0. So we'll take the derivative. And you get 4x cubed plus 2x. So set that equal to 0. Factor out a 2x. And you get 2x plus 1 equals 0. That's 2x squared plus 1 equals 0. Okay, let me just make sure I did everything correct here. Okay, so this is going to give us x equals 0. And this factor here is never equal to 0 because it's 2x squared plus 1. If it was minus 1, we could solve, but we can't because it's plus. So x equals 0 right here. And then we're going to test a value on either side, like -1 or 1. So f prime of -1. If I plug -1 in here, I would end up with -2 times a positive number, because 2x squared plus 1 is always positive. So negative times a positive is a negative. So I know that f prime is negative, or the f is decreasing on the interval -infinity to 0. Doesn't automatically mean that this interval is going to be increasing from 0 to infinity. Got to check it. So f prime of 1, if I plug in a positive number, I do confirm that the derivative is greater than 0, so f is increasing. Oops, increasing there. So 0 to infinity, choice C here. Okie doke. All right. Number 10, the maximum acceleration on the interval 0 to 3 by the particle's velocities given by v is, so be careful with this one. It's asking for the maximum acceleration. So first off, we got to get the acceleration function, which is equivalent to the derivative of velocity. So 3t squared minus 3t, no, 3t squared. Let me just erase all of that and get rid of that. So minus 6t plus 12. This is the acceleration function, but we're trying to find the maximum of this function. And remember, anytime you want to find the maximum of any function, you take the derivative, find the critical numbers, and then either do the first or second derivative test. While here, the acceleration is the function we're trying to find the max of. So the derivative, a prime of t, is 6t minus 6. Set that equal to 0. You would get t equals 1. And then the second derivative test on that, a double prime would be equal to 6. Okay, so a double prime of 1, or, yeah, a double prime of 1 is equal to 6, which is greater than 0. So t equals 1 is actually the minimum acceleration. So what are we going to do? Well, what we're going to do is remember that in this case, we have a closed interval, okay? So we have to use the candidates test. For the candidates test, the options available are the endpoints of the interval or the critical number. So we didn't even need to do the second derivative test because this is a closed interval. Don't do the first derivative test. You simply evaluate the function you're trying to find the absolute max at the endpoints and the critical number or numbers. Okay, so the t-values are 0, 1, and 3. When you plug 0 into the acceleration function, you get 12. When you plug 1 in, you get 3 minus 6, -3, plus 12, which is 9. And when you plug 3 in, you get 3 times 3 squared, so that's 27, minus 6 times 3, so minus 18, that gives us 9, plus 12 is 21. And the highest of those is going to be the absolute max, which is 21. Okay? All right, so number 11, function f is continuous on the closed interval and values in the table. The equation f of x equals 1/2 must have at least two solutions in the interval 0 to 2 if k equals what? Okay, so this is dealing with the intermediate value theorem because the function is continuous on a closed interval. So just to look at it, 1, 2, at x equals 0, you have a point here, we know that. At x equals 1, we don't know where the graph is. And at x equals 2, you have a point here. Okay, the equation f of x equals 1/2. All right, so it has to pass through that. The graph has to pass through that at least 2 times. So if the value of k is 0, that means that when x is 1, the y value will be down here at 0. Okay, so if the graph's continuous, then at some point it has to go from where it starts down there and then back up, crossing the x-axis, or excuse me, crossing the y value of 1/2 2 times. This is actually the solution. Okay, if the k value is 1/2 right here, then the graph would have to come down and touch, but it doesn't have to. It doesn't have to go through that, and then you'd only have one solution. If k is 1, 2, or 3, then it'd be like up here, or even all the way up here. And you could draw the graph in a continuous way without ever crossing y value of 1/2. So a equals a when k is 0 is the correct solution here. So number 12, the graph of f is shown in the figure. Which of the following could be the graph of the derivative? So notice a couple things, that there is a max right to the right of the origin, so positive x value. So I know that the derivative f prime is going to go plus minus. It's going to be positive then negative. And it's going to change sign somewhere just to the right of the x-axis, or excuse me, just to the right of the origin. So B is not going to be the answer because it never changes sign. Okay, D is not going to be the answer because it changes sign 2 times. C is not the answer because it changes from negative values to positive values. Okay, and then E does go positive, negative, and A also goes positive, negative. Okay, so how do we determine which one to go with? If you look here, though, the original function has concavity and it changes. It's concave up right here, then it's concave down, and then it's concave up again, which means that the first derivative is going to be increasing, then decreasing, then increasing. So it's choice A. The derivative goes positive, negative, and follows the pattern of concavity that you can get from the first or from the original function. Okie doke. All right, just a couple more. F of x equals tangent 2x, then f prime pi over 6 is, well, you got to take the derivative. F prime of x equals derivative of tangent secant squared 2x times the derivative of the inside, which is 2. I mean, 2x is the inside, so its derivative is 2. And I'm just going to multiply it out front. So f prime of pi over 2 is 2 secant squared of 2 pi over 6, which is 2 secant squared pi over 3. And now this is where it's important to know your special values of trig functions. Actually, this right here should be over 3. Okay. Secant is the reciprocal of cosine, so this would really be like 2 times 1 over cosine squared of pi over 3. And cosine of pi over 3 is a half, so this is 2 times 1 over 1/2 squared, which would be 2 times 1 over 1/4. And 1 divided by 1/4 is multiplied by the reciprocals 4. 4 times 2 gives us 8. All right, we got 2 left here. Number 14, the graph of the function is shown above. Which of the following statements about f is false? So be careful here. F is continuous at A. It's not. So, because you have a removable discontinuity. Now, it's a good idea to just check the other ones. F has a relative maximum at x equals A. Yes, that would technically be a relative maximum because at x equals A, that's the highest point near it. X equals A is in the domain of F. Yes, because the function does exist there. It's where the dot is. There's a discontinuity, but it does exist. The limit from the right is equal to the limit from the left. That's true. And E is also true. The limit exists. The function just has a discontinuity. All right, last one. Here, the graphs of the derivatives of function f, g, and h are shown. Which of the functions f, g, or h have a relative max on the interval a to b? So what we're looking for is a point where the derivative changes from positive to negative. Let me just positive to negative on that interval. So just looking, g prime does not change from positive to negative anywhere on that interval. Neither does h prime. It's always positive. F prime changes from positive to negative right here. So it would be a f only. Okay. All right, guys. Hope that was helpful to you. Reach out if you have any questions. Take care.